Okay, welcome to video S12, sign analysis and boundary testing. You're probably thinking another sign analysis video. Yeah, another sign analysis video. Um, this one is, I'm going to dive a little more into like what the actual sign analysis could look like and look ahead a little bit what could go wrong in the future. We're just looking at the same inequality testing that we have been doing. You've seen it a couple times in this series now. So the procedure is, we know the procedure, right? So we know the original zeros are going to become boundaries, and we're going to look between boundaries. Um, yeah, they're going to set the parameters for our inequality. They're not going to be the solutions themselves. So let's just dive in for a question here. This first question we could see asks us, okay, when is x minus 1 times x plus 3 positive? Okay, so our first thing is going to be, I'm going to ignore the inequality and say what's happening at the boundary. I want to know what's splitting my number line up. So x minus 1 times x plus 3 equals 0. When is that going to happen? And I can see I'm going to get x is 1 or x is negative 3. So that means that's going to break my number line into 3 segments. Now, I know there's a couple ways to do this, right? So first way I could do it is my kind of really quick sketch idea. So what we've been doing with that one is we're going to say, well, okay, I know I'm going to change signs at negative 3 and 1. I look at my original quadratic and I can see a is positive. There's a positive coefficient. So it means I open up. So I'm going to look like that. And then I can see clearly I'm positive on the outsides, negative on the inside, and I can answer the question, right? So it's going to be positive on the outsides there. Okay, that's fine. But what if I actually want to do a bigger sign analysis? What if this is a bigger question? What if I just don't like sketching? Those are all fair. What I'll do is I'm going to do a very, very similar setup. So I'll actually move this down a little bit. What I'm going to say is, again, my number line split by these boundary values, the negative 3 and the 1. This time I'm going to extend them up. I'm kind of creating a little table here for myself. I kind of missed that one. There we go. And I'm going to say what changes my sign. Well, things that change my sign are going to be x minus 1 and x plus 3. So x plus 3 and x minus 1. What do I really care about? I really care about my whole function. I'm just going to name them f, a whole function. So I'm just going to go through and test values very informally. So I want a number less than negative 3. So let's say negative 10, negative 100. It doesn't matter. So let's say go to negative 10. Negative 10 plus 3 is going to be negative. I don't care about the number. I just want the sign. Negative 10 minus 1 is going to be negative. So if those are both negative, my whole function is going to be positive. Okay, next. Between negative 3 and 1, well, let's check 0. 0 plus 3 will be positive. 0 minus 3 will be negative. So now I have one negative. My whole function acts negative. And then bigger than 1, let's try 10. 10 plus 3 positive. 10 minus 1 positive. Positive times positive is positive. So notice these signs do align with each other, right? Positive, negative, positive, positive, negative, positive. And this question said, well, when are we positive, strictly positive? So I want those edges. So my overall answer, see if I can fit it in here. I'll put it above, is going to be x is an element of every x up to negative 3 or every x greater than 1. Now notice negative 3 are not and 1 are not included. Why is that? Well, it's because of this strict inequality again, right? So it said don't include the boundaries. If I included the boundaries, I would change those edges to square brackets. Okay, here's one for you. So yours, you have a leading coefficient that's negative. So negative x minus 4 times x plus 2 is less than or equal to 0. Pause the video, give that one a shot, and we'll come back and discuss it. Okay. So there it is. I did the exact same process. The only thing that's really different here is in my true sign analysis, note that I have this negative, and I'm going to include that in my sign analysis table. So that's going to flip whatever my sign looked like it was going to be, it's going to flip it. So over here, see how I had two negatives? If I kind of compare the examples, I had two negatives here and two negatives here, but this third negative is going to flip the sign, and that's going to end up flipping everybody. On my sketch, I can kind of see that because I open down versus open up. Now, the answer in the end does kind of look the same because it is still the outsides. But here it's the outsides give me the negative. Above here is outsides give me the positive. So again, both methods are fine. The sketch is definitely quicker, but the sign analysis is a little more robust. And yeah, it's up to you. Do whatever you want with those questions. Last question. So this next question is a bit of an extension, but why not? While we're talking about this, why not kind of look ahead of what could happen? So this question says x minus 2 squared times x plus 3 over x minus 1 is less than or equal to 0. Okay, so let's take a look at what's happening here. So where could I change behaviors? And again, this is an extension question, right? So don't stress too much about this one. Let's just talk about what's happening. So I know at my boundaries, so like what's going to happen? So my boundaries are going to be, first of all, where is x minus 2 squared times x plus 3 equal 0? Well, when x equals 2 or x equals negative 3. But I also have, this looks like an asymptote, so also x minus 1 equals 0. So also x equals 1. So I kind of have three numbers I'm leery of right now. 1, 2, and negative 3. So let's go ahead and set up, let's just do a big sign analysis. We don't really want to sketch this right now. This is like a pre-cal 12 question, so we will come back for this one, just not right now. So what I'm going to do is I'm going to say, okay, let's break this thing up. So I have negative 3, I have 1, and I have 2, and let's extend that a little bit. So what are my factors? So who's kind of playing the game here? Well, so I have x plus 3, I have x minus 1, I have x minus 2 squared, and then all together that's going to tell me about f of x, the whole function. So let's start now, and you could actually start anywhere, right? So last time I started at negative, like with a big negative, I don't have to. I might say I want to start at 0. 0 is between 1 and negative 3. So let's plug in 0. So again, I just care about the sign, right? So 0 plus 3 is positive. 0 minus 1 is negative. 0 minus 2 is negative, but the square makes it positive. So what that does is I now only have one negative. My whole function is going to be negative from there. Now let's go to the left now. Let's go big negative. So negative 10. Negative 10 plus 3, negative. Negative 10 minus 1, negative. Negative 10 minus 12, negative, but the square again flips it positive, which flips this whole thing positive. Okay, between 1 and 2, this one kind of sucks. I'm thinking like 1.5. 1.5 plus 3, positive. 1.5 minus 1, positive. That's where this guy flips. And then 1.5 minus 2, negative, but it squares to a positive. So this thing ends up positive. Now here's the last one. What about a big positive? So let's try 10. 10 plus 3, positive. 10 minus 1, positive. 10 minus 2, positive squared is positive. So notice that I remain positive after this thing. And that is because, and again, this comes back next year, this was a double root right there. So what that meant is it bounced off it. It acts like a quadratic with one x-intercept. So at that root, I'm not going to change signs across it. So this question wants to know, hey, where are we at most 0, negative or 0? So I want the negative bit, and it's just right here. So the question is just going to be, our answer, sorry, is just going to be, so x can be anything from negative 3 to 1, and it's an inclusive inequality, so I'm going to include those endpoints, and that's it. Again, that's a big idea. Like graphically, we'll come back for that next year in a lot more detail, but I just wanted to kind of show like where could this lead? So again, don't worry too much about this right now, but it is kind of showing that it's not always going to be draw the quadratic one way or the other and move on with your life. And that's it. Final checklist there. So just remember, boundary split the number line, test the number of the interval, or sketch it if you can, include zeros if it's inclusive inequality, or disclude them if it's a strict inequality. Don't include non-permissible values, and then watch the double roots. And actually, As I was saying that, I just caught a little issue. X can't be 1 here. That was close. X can't be 1, so what that means is I can go from -3 to 1, but 1 is not going to be included. That was a close one. Okay, and that is it. Thanks for watching.